Good morning, students. Now I want to explain about the properties of alkanes. Properties of alkanes. Now I want to discuss about the properties of alkanes. Here, alkanes means this. In this alkanes, only sigma bond is present. Carbon is 2.5 electronegativity. These are 2.1. There is all carbon, hydrogen, and carbon bonds are non-polar. Only sigma bond is present. The carbon bond is non-polar. The electron difference between carbon and hydrogen is very less. That's why these are non-polar in nature. Only sigma bond is there. To want to break this sigma bond is very difficult. High energy is required. That's why these are less reactive. These are less reactive. Hydrocarbons. This is alkane is very less reactive. That's why these are participated only in substitution reactions. These are participated in substitution reactions, not in addition or like that. Only these are participated in substitution. That is, and also most of the cases free radical reactions will form. Free radical reactions is possible. This have to remember. Next, in this case, what are the reaction? One is first one is halogenation. Halogenation reactions. Second one is nitration reactions. Third one is sulfonation. Fourth one is halogenation, nitration, sulfonation. Next participation is oxidation. Fifth one is pyrolysis. These are some of the important properties, reactions of alkanes. You have to must remember. Halogenation means these are some important reactions. We will discuss one by one. First, we discuss about the halogenation reactions. The halogenation reactions are very, very important. Halogenation of alkanes. Have to remember here, this halogenation of alkanes will, important points, participated in free radical substitution. Undergo free radical substitution reactions will involve. We know the stability of the free radical is tertiary is greater than secondary is greater than primary. Halogenation involve halogen. Means that is reactivity of halogen is fluorine F2 is greater than, Cl2 is greater than, bromine Br2 is greater than iodine. These are the points we have to remember. Fluorine is highly reactive. Chlorine is also highly reactive. You have to remember. Highly reactive means these are less selective. This is also less selective. Bromine is less reactive but more selective. These some points you have to remember. Next, discuss about the halogenation of alkanes that is involved in substitution reactions. For if you take this is methane in terms of chlorine, HNO, sunlight used, they will form methyl chloride plus HCl. This is participated in three steps reaction. First is chain initiation. Chain initiation. First one is chain initiation. Means chlorine in presence of sunlight HNO undergo free radical Cl radical and Cl radical. This is the initiation reaction. Next, second step is chain propagation. Chain propagation reaction. Chain propagation. What is chain propagation? That is methane in presence of the Cl radical, they will form methyl radical plus HCl. Then again methyl radical will react with which one? Methyl radical plus HCl. This methyl radical again will react with chlorine, Cl. They will form methyl chloride plus chlorine radical. This chlorine radical again reacts with methane. This is like this chain propagation will start. Next to chain termination. Chain termination. What is chain termination? Here methyl radical is there. Methyl radical plus methyl radical will combine, they will form. What will form? CH3, CH3. These are the termination. Chlorine radical will combine with chlorine, they will form Cl2. Methyl radical plus Cl radical combine, they will form methyl chloride. These are the all are combined with radical, they will form methyl chloride and Cl2, CnC, CH3. These are the chain termination reactions. This is you have to remember. Next, these are the chain initiation, chain propagation, chain termination reactions. If you take here, this chlorine is excess. If methyl is excess taken, then they will form methyl chloride. If chlorine is excess, if you take chlorine is excess, what will happen? CH2, Cl2, CHCl3, CCl4. These are the reactions will form. If take methyl excess is like this, if chlorine is excess, this is the reactions will form. Next, this is the halogenation of alkanes. Important methods to remember: chain initiation, chain propagation, and chain termination. Next, we discuss about the very important. Here, one of the important method, that is halogen exchange method. We know that fluorination is really that is methane in case of fluorine HNO, which they will form methyl fluoride plus HF. This is not happen because highly reactive. This is not done in laboratory. That's why this is, for this we use the halogen exchange method. Methyl chloride, bromine, fluorine in presence of silver iodide or HCF2, silver fluoride, HgF2, stibbium trifluoride, they will form the methyl fluoride. This is the halogen exchange method. This is halogen exchange method. This reaction is known as a Schwarz reaction. This reaction is known as a Schwarz reaction. Have to remember. Next, we discuss about the iodination. Iodination is also iodination. Methane in presence of iodine, they will form methyl iodide plus HI. This is iodination. This is HI is strong reducing agent. Then again it will react with, then they will form this iodine. This is very, in order to remove this HI, we will add HiO3 or HNO3 This is converted to iodine. Iodine plus water. To remove this HI, we add the strong oxidizing agent. This is strong reducing agent. We add strong oxidizing, then we can remove this one. This reaction is forward reaction in favor. Next, we react with the which one? If you take for example, this is very important. Very important. These are very important. One is higher alkanes. If, for example, if you take CH3, CH2, CH3, in presence of chlorine, they will form two types of reactions: CH3, CH2, CH2Cl. Next, second one is CH3, CHCl, CH3. This is the primary radical. This is the secondary radical. These two are reactions. This is the minor product. This is the major product. Why? Because chlorine is high reactive, less selective. That's why this is the major product, 55%. This is the minor product. Why? Because this chlorine is highly reactive. Bromine is highly reactive, means that is less selective. That's why this is primary is major. But in case of CH3, CH2, CH3, if you use the bromine, they will form bromine. This is here. This is minor product. This is the major product. This is more selective. This is less reactive. The order of reactivity depends upon, in case of chlorine, 1, 3.8 and 5. Primary free radical, secondary free radical, tertiary free radical. In case of bromine, what will happen? 1:82:1600. This is the reactivity. We have to remember, very important. These two reactions. If in this case, what is the formation of, how many are primary carbons are there? The primary hydrogens are there. Percentage of primary is equal to, percentage of this one is equal to, how many primary hydrogens are there? 5. 1 into 5. This is equal to 5. Next, how many secondary hydrogens are there? 2. 2 into 3.8. That is, total is how much? This is proportion of primary hydrogens is 6, not before this, 6. Percentage of that is proportion of secondary hydrogens is 2 into 3.8, 7.2, 7.6. The percentage of primary is equal to 6 by, that is 13.6 into 100. That is equal to 45%. If percentage of secondary hydrogens is equal to 7.6 by 13.6 into 100, how much? This is 55%. That's why in case of chlorine is percentage of secondary is 55%. This is 55%. This is 45%. 55%. This is 45%. This is should remember. Next, in this case of bromine, how to calculate a bromine? in case of bromine, how many the proportion of primary hydrogens is equal to 1 into 6, that is equal to 6. Proportion of secondary hydrogens is equal to 2 into 82, that is equal to 4, 164. If it is percentage of primary is equal to 6 by 170, percentage of secondary is equal to 164 by 170. This is approximately, this is 99 percentage. This is approximately 0.0 something. That's why this is the major, more selective compared to this one. This is very, very, very important to remember the formation of percentage of more percentage, which one, either major or minor products, you have to remember. In case of properties of alkane, this is very, very, very important reaction. This is in case of properties of alkanes. Thank you, students. Thank you. Next we discuss about the remaining.